Hello, Greg Osborne here, the Dry Air Guy. Hey, today I'm going to be doing a small video for you about what is the best practice of piping in a rotary screw compressor, somewhere in the neighborhood of 20 to 50 horsepower, into a receiver tank, and then from the receiver tank into compressed air filtration, from the filtration into a desiccant dryer, and then out into the shop. Just a short video, but I'm going to show you all the different points along the way and the best practice for putting that whole system together. Hope you enjoy it. Today's video is best practice piping for a rotary screw compressor into a vertical receiver tank, into filters, and then onto a desiccant air dryer. So we're looking at the screen right now. And just notice my cursor moving around. I'm going to highlight our rotary screw compressor, which is right down here. I'm saying from 20 to 50 horsepower. I would term this a medium-sized rotary screw compressor from 20 to 50 horsepower. The bottom end, it puts out about 80 CFM. At the top end, about 212 CFM. So coming out of the air compressor, you've got a ball valve. And then you're going to go to a flex hose. And the flex hose is there and designed to take any vibration from this air compressor and stop it from transferring into the blue aluminum piping. Now, the piping is going to run into a receiver tank and then into the lower end of the receiver tank. What's going to happen is every compressor discharges a certain amount of water and oil in the process of running. When the rotary screw compressor is cold, it's going to discharge more oil until it comes up to temperature. So if a unit is turning on and off frequently, it's going to, on an intermittent basis, it's going to produce more oil into the condensate stream than if it's on all the time and it's up to temperature on a continual basis. As we go into the receiver tank is cool and it's going to act as a heat sink. It's going to help cool down that airstream coming from the compressor and condense liquid that's in the compressed air. That liquid then will in turn run down into the bottom of the tank and is discharged out by this automatic drain valve, ED-2-4 electronic drain valve. So this end of the drain valve will run off to some type of a drain system or a condensate removal system. Now then the air will run out of the top portion of the receiver tank and head down this way through a valve and then into a Y strainer. And the reason there's a Y strainer in here is all receiver tanks are made of steel. As time goes on, the tank will start to shed and then metal particulate will move through this pipe, come down this way and get stuck inside this Y strainer. Inside the Y strainer, in this portion, there is a stainless steel mesh that can be removed. So you take and you shut this valve off into the off position. Now it's in the off position. And the air is going to no longer go down into this Y strainer. Okay. All right. And then you can undo this little knurled end right here. Open it up. Well, you can open the petcock here first. Drain the water off of this system, and then you can clean out this Y strainer, clean the rust out of it. It's typically a magnetic Y strainer, so it will capture any rust particulate coming from the receiver tank or coming from the rotary screw or any of the piping. The purpose of the Y strainer is to protect the TD5 drain valve below. Open position, the air is going to continue coming down through. And when it gets to here, it's going to be stopped. And any liquid that's in that airstream that's condensing is going to drop down to this TD5 float drain. It's going to cause the float system to float up here and create a gap in the seat within this TD5 drain, and then the water is going to pour out the bottom. Air will then continue on this way toward the first filter. The first filter is an Eliminax water separator. It's all stainless steel mesh, and that stainless steel mesh is air and water. Moisture that's in the airstream is going to attach to that stainless steel mesh, and because there's a lot of surface area in there, and that will form large beads. Those beads get heavier and heavier, and then they drop to the bottom. And there's also a flow drain in here that will lift up, creating a gap in the seat, and then the water will drain out below this first Eliminax. The air will continue on into the coalescing filter. Now, about 95% or more of the oil and water is drained out at the first filter. So the second filter is more of a polishing filter, and it's going to remove oil down to 0.01 microns. It also has an automatic float drain to drain that liquid oil out of the system. Valves on either side of those, so if we have to change these filters, we would shut these two valves off and open this valve up here with a bypass going around the system. You'd only do that just for a short amount of time, just enough to change these filters out. The filters, I would change them every 6 months, and then always analyze your coalescing filter and looking on the inside of your coalescing filter element and seeing how dirty it is. If it's light yellow, that's fine. If it's a dark yellow, you may have gone too long. If it's black, you've gone way too long. If on the outside red portion of the filter you see a black oil stain coming through, then you've gone way too long. And then instead of 6 months, you need to back this thing way off. I would initially, if you saw that at 6 months, I would initially back that interval off to 3 months and then reassess at 3 months interval and see where you want to be. Always do that with the coalescing filter. Always make an assessment every time you change a filter out. So as the air proceeds now, it's going to drop down this pipe and then head toward the desiccant dryer. So there's another coalescing filter at the desiccant dryer. The reason for a second coalescing filter there is this is the mainline system, and we are going to be hit here with the heaviest amount of oil. So we want to always protect our desiccant in the system. If oil from a compressor gets into the desiccant, it will render that desiccant useless. It will turn it into mush, and it becomes useless, and then you have a very expensive job of cleaning these desiccant beads out. Activated alumina is a typical desiccant that's used in this type of a situation. So what we want to do is keep it as clean as possible with having this full-sized coalescing filter in front of it, 0.01 micron. It removes all the oil from the system. After you leave the desiccant system, sometimes there's slight dusting of the desiccant. It can break down over time, so we have another coalescing filter after the desiccant dryer before the compressed air goes into the main piping system and goes out into the plant. And that stops any desiccant from going downstream, protecting your processes and keeping the air as clean as possible. So this is the piping configuration that I would recommend for a desiccant system. And I look forward to seeing you on the next video. Thanks, and have a great day.